Okay, I think it's time. Let's get started. So welcome to FEA class. I'm the instructor of this semester. I'm Ting Dong. And a little introduction myself. So I graduated 2 weeks ago. I had my undergrad, my bachelor degree and master degree in material science. And 4 years ago, I changed my major to mechanical engineering and finished my PhD degree. PhD degree in mechanical engineering, and I graduated 2 weeks ago. So this is my first time teaching with a degree, but this is not my, but during my PhD, I taught different class, like the FEA class 2 years ago, and also I taught the mech design, and also the mechanical materials in the past summer. So it's not my first time teaching, so there's no need to be panicked like a super new instructor or something. So I'm teaching 2 sections this semester, the section, the sixth period and also the 8th period. And I asked the department if it's okay to merge the 2 sections into one and only do 1 live section at 6th period, and department say it's completely fine because a lot of professors do pre-recorded class anyway. So if you don't have time conflict, I highly recommend that you join the live class, because in this way you can, so anytime if you have any question during class, you can ask me, you can stop me, ask question, and I can like slow down if my lecture goes too fast. But if there is a time conflict, like you have another class also at 6th period and cannot come, then you can watch all the lecture, all the class are recorded. I will post it after class, and then you can watch all the recorded video after class. And the class attendance is not mandatory. You will not, like, if somehow you cannot attend any class this semester, you will not have any penalty for that. I recommend you come to the live class if you can. And office hour is right after the this class, so it's at 7th period. So let's say if you have any question that in this class and you don't want to ask during the class, you can ask me in the office hour. And also if something like in the homework, in the projects, and when you prepare for the exams, you're very welcome to use this office hour. And also we have 2 TAs, Miao Huang and Randy. So Miao is a graduate student, and Randy is a undergrad student in aerospace engineering. They will also have office hour. Each of them will have 3 hours office hour every week. So as you can see that our office hour is from Monday to Thursday, 2 hours per day. And on Friday, only 1 hour, because I assume that most of you don't want to study on Friday. And also, I want to say that it's not that I don't like reply email, but sometimes I feel that it's more easy to communicate if you talk with us during the office hour. For example, if there's something that you don't understand, some question you want to ask, if we use email, probably back and forth, like half an hour, is still confused, and it's really hard for me to explain through the email. But if we talk through them in the office hour, probably 5 minutes can solve everything. So I personally feel that using office hour is better to help you, and it's also, I think it'd be also more time efficient for you. So highly recommended, use the office hour if you have any question. And the textbook is the introduction of the finite element, this one. So the author, the first author, Nan Ho Kim, is my professor. Is my advisor in my PhD. So I think this is a very good textbook because it's very easy to understand. You will see in this semester, compared to other textbook, this is much easier for us to understand everything. The finite element it's traditionally very complicated topic, and also it's like heavy math. I think this textbook explains everything very well. And also the class section is recorded. The class is recorded, the office hours is not recorded. So if you have privacy issue and you don't want to ask questions during the class, somehow you can talk to me during the office hour. Office hour is not recorded. And the course content, we will do the math preliminaries first, because in this semester we will use a lot of like matrix vectors and matrix vector operation, everything. So I know that you, all of you have learned this somewhere in your previous class, but I just want to make sure that everybody on the same page. And if you are very good at it, you probably can relax in the first 1 or 2 classes. It's like a review part. If you forget, then this is a good chance that you can catch up. And for the front-end element, we will start with the bar and truss element, and then move to the beam and to the 2D element, like we use the triangle element and the quadrilateral element. And for the triangle element, we have the 3-node triangle element, 6-node triangle element. And for the quadrilateral element, we have the 8 nodes and 4 nodes. So it's like, as the semester goes, the content will get more and more complicated, but the basic idea is the same. So as you know that in the mechanics materials, we learn everything like the bar and the tension, the shaft and the torsion, and the beam and the bending, and we calculate stress, what is shear stress in the shaft and the torsion, and what is angle twist, and for the beam bending, what is the deflection, what is the stress, everything. So, but in real application, in the real world, it's really hard to like simplify a real world structure as a simple beam or shaft or a bar. So for example, if you want to do analysis of a bridge, or you want to do analysis of a like in civil engineering, a house or aircraft in aerospace. So what we do is that we discretize the real world structure into small elements, and this small element then we can consider is either a bar, a truss, or it's like a beam or a shaft, or like a 2D element. I just said the triangle element, the quadrilateral element, and we calculate everything within each element. And for the entire structure, we assemble them. And then in this way, if we know the structure, let's say a bridge, and we know the boundary condition, we know the loading condition, we can use this method to calculate the result that you want. For example, what is the deflection, what is the stress at any point you want. So it's more like a more advanced class that connecting what you learned in the foundation class, mechanics materials, and the real world application. So I know I checked your most of your backgrounds like 50 years senior, so you will go to the industry very soon or go to graduate school. So this is a very important class to bridge the gap between the foundation class and the real world application. And also, I think I have some slides I can show you. So this is the turbine engine of the aircraft, and you can see that this is the analysis of the stress of the turbine blades, and you can see the red color means higher stress, and the blue color means low stress. And when it's rotating, we can do analysis where is the high stress occur, and then we can find out where is the problem and everything. And let's see the next one. So this is a car crash model. And it's also, we can do, well, it's really, sometimes, a lot of times it's very expensive to do the real experiment to find the result we want. So the simulation can be a much better way. And let's see, this is a simulation of the sorry, I didn't know there's like this sound in. So it simulates if we have a bridge and if there's a truck drive through the bridge, and it can show what the stress change at each location, and if we have the upper limit, what is the bridge can carry, and we have this finite element analysis and find out what is the maximum stress generated if a truck drives through, then we can find if this bridge is safe or not. So I think it's a super cool thing. And let's see sorry, this one. So this is the tower. So we simulate the stress under the wind. So you can see that the high stress is at the bottom and the low stress is at the top. And let's see, oh, this is not a practical situation because it's really rare that the aircraft crash because two aircraft bump into each other, but this is just a simulation. So we can see that we have for the real world application, we can always discretize our complicated structure into smaller elements, and we use our foundation theory to do the analysis and then assemble them. So we can find everything we want. So this semester, we will learn the theory part of the finite element. We'll also learn a software abacus. So for complicated structure, of course, we cannot always do the hand calculation. So I will do like several tutorial of how to use abacus, and you will have 2 projects and possibly some homeworks. You will use the abacus to do the simulation. And this, the software abacus is kind of like, well, there are several options outside. It's like the ANSYS and some companies that use ANSYS. But what I want to say is that it is okay because if you know how to use abacus, ANSYS is very similar. So so it's more like if you know how to use MATLAB, you know how to use R, and it's not that complicated. So in this semester, we will use abacus. And course assignment, we will have 10 homeworks. We may have more because I think a lot of times students prefer like a small homework more frequently than a big homework like every week. Because in the past summer, in the mechanical materials, I assign homework like very small homework after every class, and a lot of students really like it because the set is like much less pressure. The total number of problems will not change through the whole semester, but sometimes I may have that smaller, with less problems in each homework, and we have more homeworks. So in the syllabus, I put 10 homeworks, but we will see which one is better. And if we have 10 homeworks, 2 of them will be dropped. So if we have 20, then 4 of them will be dropped. So and I want to say that make sure that you submit everything on time. It's like a lot of times students like always email me, oh, I forgot to submit, or I uploaded, I forgot to click submit, or some other problems. So I want to say that if I accept your late submission, it's going to be unfair to other students who submit the homework on time, because some students work really hard in the semester and put this homework, like put all the assignment, everything in this class as a like priority, and they may sacrifice something in the on other things to submit this on time. And if I accept your late submission, it's going to be unfair to them. So let's make clear at the very beginning, I don't accept any late submission. And if you somehow you cannot submit on time, or you have any problem that you cannot submit, you cannot do the homework, it will consider as the dropped homework. And project, as I said, we will have 2 abacus projects, and probably add one at end of this month, no, next month, and one at the end of semester. And there will be like 15% in the final grade. And we will have 3 exams. Not all 3 are at night from 7 to 9. And I have the tentative exams date, so September 30th, October 30th, and December 4th. And we don't have the cumulative final exam. All the exams are equally contribute to the grade. So homeworks, we will have homeworks will be like 10%, exams 75%, so 25% each, and we have project 15%. So these are the course assignment. And the software, I highly recommend you download this and install it as soon as possible. Because in the previous semester, a lot of students like 1 day before the project due, and they email me, oh gosh, I cannot download. There's no way I can help you in that way. So I highly recommend download this one in this week, and we will use in homeworks, we will use in the project. And if you like ask me to help you in the last minute, there's no way I can help. And there's no way you can finish the project anyway. So try to download this one. And also, I want to be honest with you that I'm not really good at a computer thing. It's more like it's like the grammar level. And I'm not good at a computer thing. So if you have problem downloading and installing on your laptop, I would recommend you either use the UF help desk or use our TA's office hour or ask your friends. So because that is most time is the computer system problem. It's not Abacus problem. So I can help you once you successfully download and installed on your computer, then I will help you how to use the Abacus, and then you can ask me all the questions. But the question about how to download, how to install, or you have problem download install, then seek for other help like the UF help desk, your friends, or our TA. And the grading scale, I think this is probably the same for every class, so I'll skip that. Grade correction. So you can always email me or talk to me during the office hour if you have some concern about your grades or you think it's unfair somehow. Talk to me and I will see what I can do. And one thing I want to say that don't leave comments on Canvas, because as you can see that we have 100 students, about 100 students in these 2 sections combined, and I also have every design class. So it's really hard for me to check your comments on Canvas one by one. We don't receive notification if you leave comments on the Canvas. So the best way that you email me or you talk to me during the office hour. So I can see if it's indeed some grading problem, I will help you correct them. Academic honesty, I would say that I have really bad reputation about the cheating thing, how to deal with cheating thing, because in the last semester, students said that I generate a lot of pressure, tension, like in the class, because I simply report every cheating I found, including the pop quiz, in the exams, in the homeworks. Because I feel that as an instructor, part of my job is teaching, part of my job is to create a fair environment. So if some students get a higher grade because of cheating, it's unfair to the other students who work really hard and didn't cheat in the exam. Because I forgot to say, so in the exams, I don't make the like surprise question. And if somehow I accidentally, I intentionally make some question that surprise majority of you and average the very low, I would curve the grade. So in the past 2 years, I think I had control everything very well except one exam. in the mechanical materials last summer. So the first exam, that one, the average was 77, and I curved it to the 80. So there's no need to be panic for the exams, but I want to say that if I find anything like cheating in the exams, I will report. In this way, I can protect majority of students who didn't cheat. And if the average is low, which is a real feedback of my teaching, I take the responsibility. It means that there might be something wrong in my teaching, and I will curb the grade for you. But if the average is high because some students cheating, then it's going to be unfair to the other students. So I think that it's better to make it clear at the beginning of the semester rather than like last semester I found cheating and then I spent time talking about again and again and again, and a lot of students get annoyed. So stay away from check and or all the other websites. And when I say it's closed book, closed note exam, don't leave any printed materials or your lecture notes or textbook around you during the exam. It's going to be very confusing for me and for TAs, and I will report, I promise. So this is academic honesty and cost evaluation. Yeah, so I would appreciate that if at the end of semester you can spend several minutes to provide a cost evaluation. It can also help me how to improve know my problems and how to improve my teaching style. And also in the exam one, I will also do a 5 points class suggestion and feedback. So it's like you have to do it. It's not a bonus 5 points. It's 5 points out of 100 in exam one. So I want to know if there's like any problem, any suggestion, anything that you want to change, and I can correct them early enough in the semester. And also, I highly recommend that if any question, any suggestion during the semester, talk to me or email me. I cannot guarantee that I will definitely change as you suggested, because this class is targeting at majority students, not at any specific students. So I will consider if majority students will benefit from this suggestion, and I will change it. So if anything, email me, talk to me. And health and wellness, I know that this is a tough time for everyone. So learning through Zoom is not that fun, but and it causes a lot of stress for students and for me as well. So I understand that. So if anytime you feel stressed or anything, it's not, sometimes it's not related to the study FEA or anything, you can talk to me and I will help you as much as I can, or I can ask some like professional help, guide you to some professional help. So don't keep it to yourself and like have depression or something, seek out for help. That is, I think that is much better. And software use, student privacy. Okay, I think that's pretty much for the syllabus. Any question? Yes, software is free. We use the student edition, and the student edition is kind of limited because like for fundamental we can only use up to 1,000 notes, but it is okay for study purpose. So the student edition is free. You're welcome. Any other question? Okay, so if no question, I think we can start from the mathematics preliminaries. Let's use this one. So as I said, we will use a lot of vectors and matrix this semester. So I will do some review of that part in the first class or possibly next class. I try to finish today. So if you are very familiar with this one, you can just relax a little bit. So math libraries. The first one is a vector. So vector is a connection of the scalars, and let's say if we have a vector has 3 components, then we can write in this way: A1, A2, A3. And also, I want to make it less confusing for the semester. All the vector we use this semester and also in the textbook are column vectors. So there's no row vector. If we really need to use a row vector, we will make like vector A transpose. So by default, all the vectors we use this semester are column vector. And if a vector is a vector in the 3D space, then we can say that this one A is equal to A1 I and A2 J and A3 K. So if A is a vector in 3D space, and IJK, they are the IJK, they are the unit vector in the XY direction, and A1, A2, A3, they are the 3 components in the XYZ direction. So let me write it here. I, J, K, unit vector. And A1, A2, A3 are components of vector. In XYZ direction. So this is the definition of the vector, and also we have the length, or we call it magnitude, or sometimes textbook is norm, and it can also be considered as the length of the vector. So the calculation of this norm is square root A1 square, A2 square, A3 square. And if the length of the vector is equal to 1, we call this unit vector. So this is the basic definition of the vector and how to calculate the length of the vector, and what is the definition of unit vector. And for vector operation, First, addition and subtraction. This one is easy. We just add or subtract the component of each vector, and then we have the new one. And we need to make sure that for the vector operation, they have to be the same dimension, otherwise you cannot do it. So let's say addition. Subtraction, and let's say if we have the vector C is equal to A plus vector B, then what we do is that each component in the C vector, in the vector C, is equal to the corresponding component in vector A plus the corresponding component in vector B. So AI plus BI. And same thing for subtraction. So in this way, DI is equal to AI minus BI. So this is a addition and subtraction. And the more complicated thing is the multiplication. So for vector multiplication, we have two different types of multiplication. One is the one is a scalar product, one is a vector product. So scalar product, as the name suggests, is the product of the two vectors is a scalar, and the vector product is the product of the two vector is a vector. So let's check both of them in detail. So let's say first scalar product. If we have vector A, we have the A1, A2, A3, and the vector B, three components also, B1, B2, B3. Then the scalar product means, let's run it this way, we also call dot product. It is A1, B1 plus A2, B2 plus A3, B3. Or we can also write this one as A transpose times B, or B vector transpose times A. So as I said, the result of the scalar product is a scalar. And if the AB are geometric vectors, vector A and B are, sorry. Then we can also write this dot product as the length of vector A times the length of vector B times cosine theta. And theta is the angle between these two vectors. So this is a this is a scalar product. So the next one is a vector product. And we normally write as this one, cross product. And if same thing, if we have a vector A1 with 3 components A1, A2, A3, and B vector with component B1, B2, B3, then this cross product or vector product can write as the unit vector in the X, Y, Z direction I, J, K, and then we have the A1, A2, A3, B1, B2, B3. And so I can write this one as A2, B3 minus A3, B2, and I minus A1, B3 minus A3, B1 and J plus A1, B2 minus A2, B1, K. So you can see that I, J, K, as I said, they are the unit vector in the X, Y, Z direction. So the product, the vector product of two vectors is a vector. So let's say, and same thing, if AB are geometric vectors, the cross product is a product that is in the, using right-hand rule, the direction that's perpendicular to the AB plane, and length is equal to the length A times length B times sine theta. So let me write it down. If A, B are geometric vectors, then A cross product B is equal to the length of A vector times the length of B vector times sine theta times a unit vector n. And the direction of n is dependent on the right-hand rule. So theta, again, is the angle between the two vectors. So let's say that if the A vector is like, so let's say this is A vector, and this is a B vector. So using the right-hand rule, we can see that, let's say this is a free space, so the n vector should be in this direction. And let's say it's a unit vector, so this is the n vector, and this is the vector A cross product vector B. And the length of the cross product is the length of A times length of B and times sine theta. So theta is angle between the two vectors. And we can see that since the vector of the direction of unit vector n depend on right-hand rule, the A cross product B should be different with the B cross product A, right? One is upward. So in this situation, A cross product B is upward. But if let's say that if it's the B, A, then it should be downward. Let's say this should be the unit vector of B cross product A, right? So let's make it less confusing. Let me remove this one. So in equation-wise, I can write it in a way that it's negative. So the length of the result should be the same, just direction is opposite. So it's a negative A times B. And if it's the same cross product of the same vector, then it should be 0 because the theta should be 0 and sine theta is 0. So let's say if we have vector A cross product vector A, then it should be 0 vector. So this is a vector product. So for like a 2x2, 3x3, or in the exam, everything can be hand calculated. So you can hand calculate everything. But if it's like the matrix or vector get larger, this semester you can use MATLAB. And in the MATLAB, let's use a different color. So if you want to do the scalar product, for this one, you can use A prime times B. Of course, you define A and B first, and then use A prime times B. Then this is it will show you the scalar product of results. And if it's the vector, I don't think they have vector. Oh, yeah, it's right here. So if it's the vector product, then we can use the cross A, B. So this is how you use MATLAB to calculate results. Of course, everything in the exam will be like, you can calculate everything, just use hand calculation. But in homework, I may make like a larger matrix and something. I can tell you, and I will tell you that you can use MATLAB. Then this is how you use MATLAB. So this is everything about vector. Any question? So if no question, let's move on to the matrix. So matrix, vector is a connection of scalar, and matrix is connection of vectors. So let's say we have the matrix M, then we can write it as, we have the, as I said, column vector M1. I use the superscript, and M2, and let's say we have n vectors, k vectors. Then it will become a matrix. And for each column vector, I can write it in a way that, let's say we have, for a random column vector inside, it has n components. So is it too small? We say subscript 1, M2, and Mn I. I is from 1 to k. So for this matrix, we define each column vector, and we get all the vector, and then become matrix. So if we expand the matrix and write in terms of each component, we can write in a way that the matrix M and each component will be M11, M12. So the first row we have K column. Oh no. Say first row. Okay, let me write it more clear. And the second row we have 2, 1, 2, 2, 2K. And the last row, let's say we have N1, N2, Nk. So this become a N by K matrix. And please be aware that the first index is the, let's do it in this way. So let's say the first index N is a row index. And the second index, K, is a column index. So the dimension of this matrix is n by k. And if n equal to k, it becomes a square matrix. So this is the definition of matrix. And for the matrix, there are several things. The first one is that the transpose. So we just, for transpose a matrix, we just switch the rows and columns. So I think it's easier just a very simple example here. Say if we have a 3 by 2, 1, 2, 3 matrix A, 4, 5, 6, no. And then A transpose. Then it becomes, we switch the rows and become 1, 2, 3 in this way, and 4, 5, 6. So this is transpose of matrix. And we can see that Aij is equal to Aji in the transpose of matrix. Let's say, for example, the A23, A32 component is 6, right? This one equal to 6. And in the A transpose in this matrix, it becomes component 2, 3, 6 here. So this is a transpose, and this is a very simple concept, but I think it's necessary to mention here. And also we have a symmetric matrix. So symmetric matrix means A is equal to A transpose. And be careful that symmetric matrix is only for square matrix. So a simple example is that, let's say we have a matrix, and then it has component 1, 2, 3 in the first row, and then 4, 5, and 6. And then the symmetric in a way that this component should be 2, this component should be 3, and this component should be 5. And this become a symmetric matrix with respect to the diagonal 1, 4, 6. So for transpose in the MATLAB, you can just use the A prime. No, not here. Let me put it here. This is how you use MATLAB. Symmetric, there's nothing you need to do in MATLAB, but let's say for a special case of symmetric matrix is the diagonal matrix, which means that all the off diagonal terms are 0. Only non-zero terms are on the diagonal. So let's see, diagonal matrix. The definition is all off diagonal term. are 0. So for example, for this matrix, it means that if I want to change it to the diagonal matrix, then it becomes only 1, 4, 6, and all the other off-diagonal components become 0. So in the MATLAB, to define a diagonal matrix, you can define first, let's say you define a vector. Let's say for this one, we can define a vector 1, 4, 6. And in MATLAB, you just use DIAG, A, and then it will generate a matrix like this. All the off-diagonal terms are 0. And the vector you generate in A will be on the diagonal term. So this is a diagonal matrix. And another concept is the identity matrix. So in this one, it's not just the off-diagonal terms are 0. The diagonal terms becomes 1. So all diagonal components equal to 1. And then we have, let's say, if we have a 3 by 3 identity matrix, then it should be 1, 1, 1, because on the diagonal components, and all the other components are 0. So in MATLAB, you can just use I, n. So n means n by n matrix. So in this way, for example, I read the one here, you can just, in the MATLAB, just put it 3. Then you will generate this matrix directly. So n is the dimension. And the identity matrix in the matrix operation is function as 1 in the scalar operation. So it basically means that any matrix multiply with identity matrix is itself. So I'll just put it here, and we will use this property in future derivation. So equal to A. Or I can also identity matrix times A equal to A. So we can either put on the left side or right side. So in the matrix product, we need to realize that it's not the same as the scalar product. We can put it on the side the result should be the same. But in the matrix product, if we put on the right side, left side is different. But here, I just want to show you that identity matrix function is 1. No matter we put at the left side or right side, any matrix multiplied with the identity matrix should be equal to itself. So this is the identity matrix, and you can see that identity matrix is a special case of diagonal matrix. And diagonal matrix is a special case of symmetric matrix. So to be a identity matrix, it should be a diagonal matrix first. So all the off diagonal terms should be 0. And as to be a diagonal matrix, should be a symmetric matrix first. So you need to understand the relation between the 3 concepts: symmetric matrix, diagonal matrix, and identity matrix. And the next thing I want to talk about is we have 5 minutes left. Determinant of the matrix. So again, this is only for square matrix. If it's non-square matrix, there's no way you can calculate determinant. So let's say if it's a 2 by 2 matrix, the determinant is easy. Let's say we have the A component with, oh sorry, I thought it's 150, sorry. I will finish class now. Sorry, my mistake. I will stop this recording. If you have any question, I will go to the office hour. Sorry, the first time, I don't know what I didn't know it's ended at 1:40. Thank you. So if you have any question, come to my office hour. I can answer all your question, or a general question through this semester. I will answer you the question in the office hour link.
Thank you.
Thank you.
Thank you.
Have a great day. Thank you.
Thank you.
Thank you. You're welcome.
Hey, Professor.
Yeah.
Can I just ask you a quick question right now?
Sure, sure.
Just a comment on what you were saying with the identity matrix,
Yeah.
the placement of the I of the identity matrix with matrix A.
Yeah.
You said it matters when you're doing a vector product versus a scalar product. Is that right? It doesn't matter.
No, I said the I matrix in the matrix operation function as the 1 in the scalar operation. Yeah, so it's like in scalar operation, everything multiplied by 1 is equal to itself. So in the matrix operation, any matrix multiplied by I matrix is equal to itself.
Gotcha. Okay. Got it. Okay. Thank you.
You're welcome. Have a great day.
You too. Bye.
Bye.